Hi, today we'll be coding something like this. We'll be animating it as well, so wish me luck, because it's just one of those things that requires a bit more effort. Generally, I really like mathematical geometric demos because you just write 2-3 lines of code and poof, there's a ton of things happening on the screen. But there are exceptions, such as in this case, where we need to write a bit more code. You can't just do it in 30-50 lines of CSS. And the more code you write, the more chances of something going wrong. And that's one thing I try to avoid, because nobody really has the time to listen to me go, oh, I wonder what went wrong here too, for 50 minutes or something. Anyway, let's get into it, and we are going to start by trying to understand what is going on here. So basically we have two spiral stairs that go around each other like two really bendy arms, tentacles, whatever you want to call them. So they go around each other 3 times. Basically they rotate around a full circle 3 times. A full circle has 360 degrees, as illustrated in this demo, which is interactive and you can play with. It's going to be linked in the description, but for now let's go back here. Okay, and these stairs are made up of steps. Each of these steps is a quarter of a donut with a hole in the middle, because you also have those ones that are filled and don't have a hole in the middle, and sometimes they're even better. I once had an apple and cinnamon one, which was absolutely amazing. But for this purpose right here, we are going to need those kind of donuts with a hole in the middle, and take a quarter of a donut, and that's going to be one of our steps. Now, per rotation, we are going to have a number of steps that we'll be setting right here. So the number of steps, or quarter donuts, whatever you want to call them, so the number of quarters is going to be 48. So this is going to be per rotation. Then we're going to have the number of rotations, which is 3. Then the number of arms, 2. Then we are going to get the total number of steps per arm, which is going to be P, the number of quarters per rotation times the number of rotations, and then the total number of steps per demo, which is going to be that P times the number of arms. Okay, having done this, we're going to put everything within the body, and within the body everything is going to be within a 3D assembly. And we need this assembly, and we don't put just the steps inside the body because of a gotcha, which is explained right here. Okay, this article is going to be linked in the description and you can check it out. But for now, let's go back here, and we're going to have a loop. So while Q gets decremented and is still positive, we create our step elements, and that's it for now. We are going to move on to the CSS. We'll be back to that, but for now let's just put something on the screen. So if you've seen my previous videos, then you know I like to do this on the body and on all div elements. If I could use a keyboard, that would be great. We are going to set display grid, and now let's put something on the screen for our step elements. First up, how do we create a quarter donut? Well, we're going to do that with borders. So we're going to have a border width, let's say something like 9 is going to be the base one, and we're going to have padding, let's say 1 Okay, and here basically we're going to want all these elements to be stacked one on top of the other, and we're going to do that with grid area. So place them all in the same cell at the intersection between the first row and first column, and then we're going to have border solid, use that border width, and also set the padding to that value. Okay, this does not look like a quarter donut. First step, set here, place self, center. The default is stretch, which is why it looks stretched initially. Let's also make it round, because at this point it's a donut with corners. So border radius 50%. Okay, now it looks round, and we also want this in the middle vertically, because at this point it only looks like it's in the middle horizontally. Thing is, at this point the body takes the height of its content, which is these step elements stacked one on top of the other. So if we set the height of the body to the full viewport height, Okay, we get an ugly scroll bar, and that's caused by the margin. So if we zero the margin, then the scroll bar disappears. Okay, now having done this, we are going to want to have just a quarter. So we're going to get just a quarter by setting their transparent, and then border top color to something black for now. We are going to change this later, but for now let's just leave it like that. Now another step is going to be set on all div elements, transform style, preserve 3D. Again, this is explained in this article, things to watch out for when working with CSS 3D. I just wanted to set it now so I don't forget about it later, because sometimes that happens. So here we're going to set a transform, and it's going to be, let's say, rotate X 60 degrees, and of course we're going to want to have a perspective there. Let's say 35 ems, that should do. Okay, now we are going to want those to be offset in this plane. So we don't want them in the same plane, we want them offset along their z-axis. So in order to do that, we are going to need to pass a few things to the CSS as custom properties. So first up, in a style attribute right here, we are going to have the number of quarters set to that value. Okay, so having done this, we are going to have something similar right here, except it's going to be the number of arms. Okay, and then another value here, and this is going to be the number of rotations. So like this. And then we are going to have a style element where we're going to set indices. So we're going to set arm indices, and we're going to set the indices of the steps on each arm. So first up, we are going to have a loop, and this loop is going to go through all the arms. So let I going from 0 all the way up to the number of arms, increment this I at every step, and here we are going to have step, nth child. So basically all the elements after the elements on the previous arms, so after the elements on the previous arms, that's going to be I times p, because we have p steps on each arm. Okay, plus 1, because nth child index is 1 based as opposed to loop index, which is 0 based. So here we'll be setting I set to the loop index. Now we are going to take this loop, and we're going to have a second similar one. This one goes up to p, and here we're going to have every p elements, right, I, and here is going to be another index j. And now we can just maximize the CSS panel because we won't be needing to go back. Okay, so first step, we are going to compute that p value here. So yeah, we could have just passed it as a custom property, but we're going to compute it here. It looks more logical. So the number of quarters per rotation times the number of rotations. And here we're going to set a progress along the arm, and this is going to be k, and it's going to be j, the index along the arm, divided by p, which is the number of steps on an arm. Okay, so having done this, we are going to set a transform, and we're going to have a translation along the third axis, and this one is going to be calc, and let's say that we are going to use an offset. So between the steps we are going to have an offset, let's say 3 pixels, something like that. Okay, so here we are going to have so let's first use the j value times the offset, and of course this is going to look really ugly and it doesn't look like anything. Let's also set a box shadow. You are going to see in just a moment. We are not going to leave this permanently. A red box shadow, so you can kind of see stuff. You can see how it's stacked there, but they just go up and we want them to go up and down. So we are going to compute a middle index here. So this is going to be calc 0.5 times, and this is basically the average between the first index and the last one. The first one is going to be 0, the last one is going to be p minus 1. So 0 plus p minus 1 divided by 2 is basically 0.5 times p minus 1. That's our middle index, and here we are not going to use just j, we are going to use m minus j. Okay, so now you can see how they go around the midpoint. Okay, good. Now we're also going to want to make them smaller as they go up. So this means that we're going to need to change this value a little bit. So we're going to use a calc. Of course, interpolate that value because otherwise it's not going to work inside the calc. And we are going to use that progress k. So k times, you can see how things are changing. And here, without the solid, I selected too much. This is going to be times p. It doesn't have that big of a hole in the middle. That depends on the donut. But, you know, if you have too big of a hole in the middle, then you're basically paying for air, not for donut deliciousness, okay? So, having done this, we are going to want to have some rotation. So, rotate, and we're going to have two components here. Basically, one component is going to depend on the arm. So the arm index over the total number of arms, and it's going to get multiplied with the number of turns, right? So now you can kind of see something, and let's also maybe this makes it a bit more I'm not sure. It makes it more obvious, but let's say that we are going to change this color. So we are going to use an HSL value, and let's say that first off, the saturation lightness, this is going to be a list that's I don't know, let's say 95 saturation, not quite maxed out, and then let's say that we are going, no, 50%, because 100% is going to be white, right? So here, actually, let's also add an alpha, and let's say that the alpha initially is going to be 1 there, but for now, let's say HSLA, and for the hue, we are going to use calc I times 180, and then we're going to have saturation lightness alpha there. So let's see it. Okay, so this now looks a bit more interesting. Let's get rid of that rotation there. We won't quite need it. Let's leave it at -5 degrees, maybe 15. Okay, so now you can kind of see how things are happening, and why I said that we're going to have a second component here. So the second component here, this one is going to be j divided by the number of quarters per rotation. So the number of quarters. So now it's starting to look better. Let's get rid of the red. So if we make it black, you can see how but it's not that thing. You can see how here we have a shadow. So we're going to do that by adding 2 pseudo elements, and we're going to move some of these styles on the pseudo elements. So we're going to have before and after, and as I said, we're going to move some of these styles on the pseudos. Well, these styles, we're going to move them on the pseudos, and here we're going to have content, nothing. Okay, okay, yeah. Oh, of course, we are going to need to keep that right here as well. Of course, we need to keep the grid area. Okay, so this is starting to look more like something, and here we are going to have a second. So here we're going to have another translation just for one of the two components. So first, let's say that we're going to have a switch which is 0 on the before, and we change its value, we switch it to 1 on the after. And a bunch of things are going to depend on this switch. So for example, let's say that we're going to move this as well, because it's going to depend on the switch. So for example, the saturation, this one, it's going to depend on the switch. So it's going to be the switch times 95%. So basically the before is going to be is going to have a saturation of 0, which means it's going to be grayscale. And here we again are going to have, let's say that's going to be the switch. So basically our three components, let's just put them one under the other, because it's going to make things a bit easier. And we're also going to compute the negation of this, so not s, this is going to be calc 1 minus s. And I actually did an article about logical operations in CSS, and that's going to be linked below as well. Okay, so having done that, let's change something right here. So this is going to be calc 1 minus, and we're only going to subtract something for the before, so for the not s value being 1. So let's say we're going to subtract 0.5 times not s. Okay, and we're also going to have, as I said earlier, transform, and first up we're going to have translate along the third axis, and we're going to translate by that offset, but only the before, right? And we are also going to, so let's say, and we want it to be above the previous after, so we're going to have a 1 pixel buffer to fix things there, times So the before, we're going to use not s times that offset, right? So let's get rid of that box shadow because it's just going to mess things up. And let's also have a rotate, and this is going to be, again, we're only going to rotate the before, so calc, everything is going to be multiplied with not s, because for the before not s is 1, okay, s is 0 and not s is 1. So this rotation is going to be basically, it's not going to be a full angular difference between two slices. Let's say it's going to be half of it. So it's going to be this, obviously divided by the number of quarters per full rotation, but we're not going to multiply with a full rotation, we're going to multiply with half of it. So how does that look? Not quite as expected. Okay, like this. So now let's set a background here, and it's not going to be quite black, but it's going to be pretty dark, something like that. Okay, that looks good. Let's also set overflow hidden, get rid of those scroll bars. As you can see, it's starting to look like something. And let's also add up a filter to soften the edges of that before. So again, since we only want it on the before, we're going to use calc, and we're going to multiply everything with not s, and I don't know, 7 pixels, something like that. And you can see how it's starting to look like what we have here. As I said, we're going to want to also animate stuff and make those arms a bit more interesting, make the colors a bit more interesting. And right now the perspective looks really weird, so let's try to fix that. And you're going to see what I had in mind by setting those two values right there, up there, and not on the 3D assembly. So let's say, so first off, let's get rid of that part. Let's make this 90 degrees. And let's change the perspective origin. So here we're going to have 50% horizontally, and then for the vertical component we are going to have calc 50% minus. So so here we are going to have m times that offset, and we are also going to subtract the border and the padding. Let's see it. Okay, so it's starting to look like something. Now let's say that we're also going to have a translation. So let's say translate y, sorry, vertical, right, minus that border, so something. Okay, make it half the border. As I said earlier, this kind of demo is a bit more work because there's a lot more tweaking, a lot more things that yeah, I look kind of wrong because there's just so much happening. So yeah. Okay, now having done this, we are going to want to have an animation. So first off, we are going to use this as just a position, base position, and then we're going to set transform, and it's going to use that position. Or it can use rotate one turn, and this isn't going to change anything. Okay, that's not what I had in mind. What did I mess up? Okay, that is completely weird. So suddenly, so that worked fine, right? Transform, let's say this is going to be position. Oh, I just figured it out right now. You need to interpolate this, right? That's the problem. So that's the problem. Okay. Rotate one turn. Okay, now this looks fine again. Keyframes, rotate, and we're going to start from 0%. Transform, and we're just going to use that position, right? Something like that. Then we're going to have animation right here, and that rotation animation, let's say 8 seconds, linear, infinite, and that's pretty much it for the animation. Let's see it. Okay, let's change the direction. So it looks kind of weird this way. Oh yeah, looks much better like this. Okay, now having done this, let's, okay, we have that rotation right there. What can we change? We can change that hue right there. We can make computing it more interesting. So let's say that this value right here, it's going to be I plus, I don't even know. But I know that I don't want to go halfway. I just want to have a bit more. So let's say that we're going to have another animation. So keyframes, and this is basically going to be like a color, and we're going to go to, we're going to take this from here, paste it there, and use a different value there, so something like this. And then we're going to have an animation. So it's going to be that color animation, and let's say that we are going, let's set an animation duration t 1 second, right? So this is going to use that t, but only for the after pseudo. So we're going to have calc that s value, which is 1, just for the after, and of course we're going to need to interpolate that part, right? And then we are going to have a delay. Now the delay is going to go along the arm. So basically I'm going to have that arm progress, or actually let's just use J over the number of quarters per rotation, so like that, and we are going to multiply this with -2 the animation duration. So let's see that. That's kind of weird. Okay. I'm not seeing the animation. That's the problem. I'm not seeing the animation working. So there's something wrong there. Let's see it. Oh, wait. The delay is, yeah, I'm not going to see it unless I set infinite alternate, because the delay is way too much, and I just have one animation. The delay is way too much below 0, and I just have just one iteration. That was the issue. Okay, so having done this, much better, we are going to set animation play state paused, because I don't think they need to change the color, and animating the border color is a bit too much for my laptop performance wise. Okay, that looks kind of weird. Let's see how it looks in debug mode, because that should have worked just fine. Sorry about that. Debug. I can't even type that. I mean, I was worrying. Yeah, it looks good in debug mode. I mean, sometimes you do get a feeling that it should work, and for some weird reason, I don't know. I've had this issue when there was something really performance intensive and animations were out of sync for elements, and it was an obvious issue with performance and my laptop not being quite there. But yeah, I kind of had a hunch it was that in this case as well. So yeah, I'm not going to tweak this any further. It already has performance issues on my laptop, so better not torture it more. I hope you've enjoyed this video, and if you like the work that I'm putting out since early 2012 and you want me to be able to do more in the future, please consider supporting it. You can do so by being a cool cat and becoming a patron on Patreon. The link is going to be in the description. Or if monthly support is not your style, there's the option of a one-time donation. Again, the link is going to be in the description. Or you can make me happy with a gift of my wish list. Links are going to be in the description. What a surprise! The links for everything else, all the resources, the finished product, they are going to be in the description. Everything's going to be in the description, except the kitchen sink. Anyway, I hope you've enjoyed this video. Thank you for watching, and I'll see you next time. Bye!